Hello and welcome back to another coding session with Mr. Jacob. Today we want to develop our Tetromino timer, TetroTime. I have actually in the meantime named this thing further. As you can see, in the last session we implemented the system which allows us to draw all kinds of different Tetrominos, those neat little Tetris characters on the screen within our terminal here, which are falling there, and calculate their collision with other Tetrominos already there. Our end goal here is to actually create a system which is capable of displaying us a clock, a stopwatch, and a timer based on falling Tetrominos down the screen. We have left off with actually what you have just seen there. The only thing I just commented out here quickly was the system we had in place to create new Tetrominos by pressing the space bar, and I've simply removed this if statement to quickly fill up the screen for a nice little intro to our video here. What we want to do today is we want to get going the drawing of digits based on the Tetromino structure we have created. I have actually done something that in the meantime I have introduced rotation. So what I have done here is I have simply added to our drawing code, where's our draw code, render or draw, how did we call it? Let me see. Render, I guess, yeah. We initially only checked for the type of the Tetromino, so an L, for example, type, or a square type, or a T type, and then we created the corresponding pixels on our screen. What I have now done is I've introduced rotation. So what we now have here is we have a simple enumeration here called rotation, which specifies like the degrees we can rotate this thing. And I have then simply added, that's actually the collision detection in code. I've simply added the corresponding rotations here and just allow the engine to draw a Tetromino in each rotation. That's not very interesting to watch me doing actually, because it's just typing down all of this stuff. I have done the same thing with our collision detection code here, which essentially does the same now for each type and each rotation. And then furthermore, I actually used this one here. Let me quickly show you this one. I used this document here, which I found online, to actually implement all of those different rotation angles. So this is the document. It is linked in the source code if you are interested in it, which has all of the different rotations. So this is the 0 degrees, the no rotation, this is 90 degrees, this is 180, 270, and this is then 0 again. And essentially what I realized is that there are two more Tetrominos which we didn't implement before. We didn't implement this mirrored L shape, which is actually kind of a J shape, and we didn't implement this mirrored skew shape, which is a right skew or a Z shape. And I have therefore implemented them as well, exactly as we have done before. Okay. Furthermore, there are more good news I just remembered. In the meantime, I have actually extracted our PixelLoop library really into its own library and published it on crates.io. So it should actually be up there now. So let's see, crates.io, and let's quickly search for PixelLoop. Yeah, perfect. There it is. So we now have this PixelLoop engine here with examples, and I've added a lot of documentation there. Let's see if this has already been created yet. No, it has not been. It will be. I've just more or less recently published this. So the idea is now that we have this as a simple crate, and now we can have our projects as our own repositories. Most of them that we did before, as you can see here, I've splitted them out into their own repositories, for example, our sense simulation or our fireworks thingy, and they are simply now opening and loading as a dependency our PixelLoop engine here, which makes things a lot nicer to be used. And I've done the same thing with our Tetromino timer. So if I go back one more and go down here, where is it? TetroTime. It's now its own repository. I will link it below in the description, of course, or you can get it through the old repository where it is linked, as you have just seen. So just for you to know that we now have our own repository where this actually lives in. So this is the target folder which all the compiled stuff is in. So maybe I should do a simple ls. Yeah, as you can see now, we have a lot less stuff in here. Okay, but now let's get going and let's implement those digits. And as you might have seen already on YouTube, where I published a little note with the information that last week I was unable to create a video because I was ill, unfortunately. But I'm very much better now and can therefore hopefully code through this session here with you and create this video. I have already sketched out, where is it? Open docs, Tetromino clock digits. I have already sketched out those blocks that we need to actually display all of the different kinds. Can't I do this? Yeah, exactly like that. So that we can have a 0 or a 1 or a 2 or a 3 or a 4 or a 5 or a 6, 7, 8, 9, and so on. So all of the digits I have more or less built up how we can actually create those from the Tetrominos falling from the top. And essentially now we should more or less be able to implement a way of having those digits displayed by having them fall down from the top. So I guess that is exactly what we are going to do here now. So let's move over to our editor and let's take this window with us. Okay, so now let's maybe move it to the left side. Can we actually make this a little bit, yeah, maybe like this? And of course now my face is a little bit in the way. However, I guess what we need to actually implement this is this window as well. So I guess maybe we can put that there. And yeah, I know that you might not be able to perfectly see this, but mostly I will need to see this in order to determine which of the rotations I actually need to draw here. I'm sorry for having this a little bit smaller if you are on a mobile device, but I guess we will kind of have to live with that while we are implementing those digits. So how would we actually do this? My naive approach to this is that we kind of implement sort of a list of information on which Tetromino, so which shape, in which rotation, at which position by having a linear list, and what x value movement from this bottom left initial thing here, so kind of a delta x, this Tetromino should fall. And if we have this list, we should be able to have them fall down one by one and essentially create the digits. That's at least what I'm currently thinking about. So I guess we could do this by simply going into our main here and more or less loading maybe another module called digits, I would assume. And then we should be able to create a new one, yeah, digits.rs, okay. And let's create an enumeration, I guess, called digit, yeah. And I guess this one will simply be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, that should be all the digits. So that we now have a way to explicitly provide them, to specify them in some defined sort. Okay, now we need a way to define all those different animation steps, I guess. And to do just that, how could we actually do that? maybe we could have some sort of struct calling falling Tetromino or something like that. I'm not 100% sure. Or animation step, or we will see. Falling Tetromino for now. We can rename it later on. So, and what we now need is we need this information that I have just talked about. So I guess we need the shape, which would be a Tetromino shape, I guess. We need the rotation, which would be a Tetromino rotation. And then we need this dx value, which is an I64 specifying where relative to the left down edge we need to be. So let's maybe import this Tetromino stuff here from our crate. And do we need anything else? Do we need a color? Maybe we will need a color if we want to be able to specify that in the animation to make it look nice. I don't know yet. However, shape, rotation, and dx should essentially be all that we need. So let's make, as always, the creation of this a little bit easier for us. So impl falling Tetromino, pub fn new, and it returns a self. And what does it actually take? I guess it will take a shape, which is a Tetromino shape, and maybe we don't need to prefix all of that, but can directly import it. I guess that makes a little bit more sense. So let's use shape, rotation, and dx, which is an I64. Okay, so and we return a self, which we of course have to implement here. So I guess this will be a simple self with shape, rotation, and dx. Okay, so now we have this. Now, how do we actually get from those digits to those falling Tetrominos? We could implement something like as falling digits or as animation or something like that on the digit enumeration, which would kind of be maybe a good idea. Oh, I have an even better idea. We could implement from, no, wait, it is into, isn't it? Into vec falling Tetromino for digit. Does this actually work? Can we do that? Okay, it seems we can actually do that. Okay, that is kind of a neat idea. I'm not 100% sure if I really want that. However, we can always implement that and then simply have something like into animation or something like that on a digit as well. Okay, let's fix this up here at the top. But however, I like the idea that I can just kind of cast a digit into a vector of falling Tetrominos and I get the list to be used for animation. Okay, that actually is a neat idea. So I guess what we now need to do here is we do a match on self there then. And then let's have it fill everything up and let's start maybe with an easy one, maybe with a 1, or yeah, let's start up with a 0. So what would that actually be? That would actually then be a vector of sorts. And the vector would need to describe this structure here. So what we would have here is we would have something like falling Tetromino new. And we would have that how many times? The biggest one here is 12. So essentially 12 times. So let's add that. And then we can actually fill those out. So what we first need is, yeah, one of those J shapes, isn't it? So we have the J shape that actually is a J, and it is rotated by, oh, you can't see, I'm sorry. So let me scroll this down a little so that you can see it more or less. So we need this J shape and we need to rotate it by 90 degrees. So yeah, I guess then we are just doing that. Can we make our life a little bit easier by doing something like use shape star and use rotation star here so that we don't need to always prefix this thing. Yeah, perfect. So, and I need degrees 90 and I want dx. Dx actually is, we are always taking the lower left corner of those things. That means that the dx value here would be 0, 1, 2, 3, sorry, 0, 1, 2, 3, 4. So it would be 4 actually. Yeah, that kind of makes sense as all of those things are 6 by 10. Okay, so the next one would actually be this one, which would be a straight. And we would need to rotate it by 90 degrees as well. So degrees 90, and it would be at position 0. The next one would be a 3. That would be actually a skew, wouldn't it? So yeah, that's the usual skew. So skew, and it would not be rotated anyway. So rotation, and the position would actually be 0, 1, 2. The position would actually be 2. Okay. I can tell definitely one thing that I actually definitely dislike currently, and that is that we have those different namings here. We named some of them like the alphabet characters, and some of them, let me just take a quick look at this shape. So some of them are actually named like L, J, T, and so on. And the other ones are named as they are written. So we have a square, we have this straight, we have a skew, and we have a right skew. I don't like that actually. There are namings, I've read about that in the meantime, for all of them that are defined by a character. And I guess I want to change that. So the square would be an O. The straight would be an I, which both make sense. The skew would be the S shape, and the right skew would be the Z shape. And I think I like that better. So I guess I will work with those from here on. So yeah, because then we have the same naming system for all of those. Yeah, I like that better, I guess. Yeah, so let's quickly see. We need now a T shape, which is rotated by 270 degrees. So this is a T shape, and it has a degrees by 270, and it should be in place on position 1. So let's get it there. Then we have another T shape, which is rotated the other way. So it is actually degrees 90, isn't it? And it needs to be at position 2? No, 1 as well. And we have, what is the 6? The 6 is actually a Z shape now. So a skew shape that is mirrored, which should actually be rotated like this one. So it is actually a degrees 90, I guess. And it should be at position 4. And now, okay. And we have a typo here. Wait, digress. The degrees, of course, it should be. Okay, so essentially now we should be able to convert our digit 0 into something that should actually create, when we have all those things falling in the right order here, a digit 0. So let's go back to our main.rs and see how we can actually implement that. I guess we need something now that kind of keeps track of how and where we put all those things. So we have this board, and currently this board holds all our Tetrominos. The question is, do we want more than one board now? Do we want to kind of multiplex? I guess the easiest way to do it, like to do something like that, would be to create a new struct and call it something like digit board. I'm not sure about the naming at all, but in what I'm currently doing here. But however, let's see that we get it working first. And this one would actually have a real board. So let's maybe put that below the real board. So as the board has all our drawing code. So the digit board. And we have a real board in here, and we should have something like an X coordinate of this thing so that we can kind of position it somewhere, I guess. And we need a Y position? No, we don't need a Y position. The question is, do we need an X position? Doesn't our board have an X position? Let me quickly check that. Our board does not have an X position. Okay, so we essentially need an X position, don't we? Yeah, okay, that makes sense. Then let's have this X position here, or let's call it X offset, because essentially this is the offset that we will be using when introducing new characters. Okay, that makes kind of sense. And then we need something like maybe falling Q, some sort of falling Q, which will be a vector of falling Tetrominos. Or Tetromino, would it that then be, wouldn't it? Okay, I can't import that one. Didn't I? Wait a second, I did not make it public. Yeah, I need to make this falling Tetromino thingy here public. So now I should be able to import it. Perfect. So we need this falling Q, or let's just call it Q, I guess. Maybe we can call it animation. Let's call it animation. And then current, or just index. That will be our index into the current animation array. As I've said, I'm not really sure about the naming here. Okay, so now let's impl the digit board. And the digit board should actually then have a pubfn new, which takes actually an X offset, which is an I64. And does it take a digit, or do we, I guess we want to be able to somehow set that in the future. Maybe we do not implement a new yet. However, we can actually, or yeah, let's implement a new. We will need it anyways. So we give it an X offset here, which is an I64. And for now, we simply return a self now. And what we will do, we will simply statically put all those. What the hell did it do there? Self, it suggested something, but it was not very clever in that. Okay, so we have a board now, which is a board new, I guess. And the X offset there, and the animation, and we simply hard coded that, I guess. So we put a digit. Oh, that is nice. I should now be able to do something like I put digit 0 in here, and it should, wait, no, I didn't want to I wanted to import that. Yeah. So why is it not now capable of converting that? Mismatch types, expected struct, whack, falling, tetromino, found enum digit. Yeah, however, call into on this expression to convert into. Okay, so can I do this now? And it, okay, that is actually really nice. So my idea kind of panned out. So now I set the index to 0. Okay, nice. And now we need a way to, I guess, implement our usual update and render functions here. So what we need to do here is we need a pub fn update, and we need a pub fn render. And render is actually something we need, of course, take a self, and we need a canvas, don't we? So it's a mutable canvas actually, which is, come on, which is a canvas here that we have, that is PixelLoop canvas. Yeah, and we, I guess, simply only put this through to our board, because our board already has all the rendering stuff. We only need to really handle update, I guess. And I guess we will need a mutable self here then. And maybe a canvas for collisioning stuff. And I'm not 100% sure, but however, let's see. Yeah, I guess we will need a canvas because we need to calculate to pass it to the board, and we need it for collision detection as well. However, we only need a non-mutable reference to a canvas here. Okay, so now that we have that, what will we actually do here? I guess we definitely will call board update and we will pass it the canvas. So we will simply pass that through. However, we need to somehow put our animation steps in there, our next animation steps, which would be something like self dot, so we will need to get, first of all, we need to if self animation dot len is greater, self dot index is less than animation length, then we will do something. Because if we don't have any more animation steps, then we don't need to do anything. So I guess the thing that we definitely need to do in the end is we need to advance our index by 1. That is something that we definitely need to do. So we can already do that. And then we want, let's see, we want simply to add a new Tetromino from our animation. So I think we can do something like, how did I call that? Falling Tetromino, yes, and it had a shape, a rotation, and a dx, and we want actually something like, we want that from the self animation, and we want that one from self index. And this does not work. Why does it not work? Because cannot move out of, okay, that kind of makes sense because it can't copy this. However, that actually shouldn't be a problem, so let's maybe maybe I could just reference all that stuff. However, I really don't care if it is copied actually, so maybe it shouldn't be that hard on the CPU. So maybe let's derive our usual usual things here like debug, copy, and clone to just make it yeah, you don't like that because you can't have that with shapes, so let's just have them to be copyable and clonable as well, and the rotation should then be copyable and clonable as well. So now it should actually be able to do that. Perfect. And now can I actually do this? I still can't do that. Why? Oh, because the field is private. Yeah, kind of makes sense. Okay, let's maybe for now just make them public, I guess. We can see if we really want to do it that way or if we want to make it a little bit neater in the future. Okay, so now we have this information. So I guess we only do something like self board.add Tetromino at our self.x offset plus our dx from the falling Tetromino at a y position of 0 with, oh, the color is an interesting thingy here. Let's maybe do let color from RGB. Let's for now just hard code a yellow color or something like that. Just for testing purposes. Then we put the shape in there and the rotation. So now we should actually add, with every step where update is called, we should actually add a new Tetromino. And this might be too fast to actually look good, but however, it should work. So yeah, and it should then advance the index. And okay, so if we now go back to our main RS, and we do not store a board in our state, but we store a digit board here. And we do, come on, digit board new, and we give it something like 20 offset or something like that. And now we actually do not have this manual adding at all, but we simply call board update now. So once we actually trigger this process, it should start rendering things. Let's see if it actually does. So, okay, that kind of looks like a 0, but not really. So maybe having all of them the same color, and it is not yellow but magenta, what I created there, isn't the best of ideas. So let's maybe go ahead and fix that by simply doing let color equals color from RGB, and let's maybe do some randomness here. So let's get the we don't have a random number generator here, do we? So what we need here actually is we need I mean, I can quickly hack something that is not that efficient and not... Okay, let's do random, is it, I guess? Isn't it? So if I import this, can I do this? And it should actually be a U8. And I want actually 3 of those. And then I do that. And now I should have a random color. It's not perfect because it uses thread local random and stuff like that. But nevertheless, we should now have different colors. Okay, now we should be able to better see what's happening there. There's definitely something wrong with collision detect. Is it collision detection wrong there? Or is... Let me make this a little bit bigger so that we can better see maybe what's happening there. Oh, now of course the... Damn. Now the programmed Y offset is not working properly, of course. Where did we actually initialize this? I guess that's part of the board, isn't it? Yeah, the virtual Y stop. So let's maybe set that to 20. We have to properly map this based on the size of the terminal, of course. But for now, let's see. Okay, this looks a little bit better. So maybe let's get our sketch over here to see what actually happened there. Okay, so of the sketch here, let's re-render. Okay, so what actually happened now there? That there is something wrong with the... Can't I move this down a little bit at least? Let me see. Maybe like this. Okay, it's not perfect, but it will have to do. There's just one of those J shapes above here in the corner. Okay, that's actually that, and that is actually rendered correctly. The problem is that this one is actually rendered, this 11 here, this Z shape is a problem, because why is it down there? It kind of... Oh, I guess... I guess I'm spawning those things too fast, and as we are all of them putting... We put all of them at the 0 position of the screen with their bottom corner. So they actually fall wrong because I'm spawning them too fast, because they are colliding while falling. Okay, let's quickly check if this actually is the case. So let's go back to our editor here. Let's, I guess we don't need this for now, so we can make this window a little bit bigger here. Let's see, where do we actually have now our digit board? Okay, so let's make this a little bit slower. Let's do something like, okay, something like, let's just a crude hack. Updates since last. or something like that. Yeah, that's not a good name. However, we won't keep it anyways. We will, I guess, do that in a better way. Updates since last anim starts with 0. And we then simply do something like if self-index and so on and so on, and self updates since last anim is bigger than 3 or 4, 3, I don't know. Then we do that, and it is always, and then we will do self updates since last anim is then 0 when we actually updated something, and otherwise we will self updates since last anim plus equal 1. And this should actually make it slower so that it only spawns with 3 update counts should then only spawn the character, yes. And now it works. Okay, that makes sense. That makes perfect sense. And actually, I kind of like the speed of them falling down to create this this 0 there. Okay, that's actually really cool. So let me get this thingy here over to the other screen again. Okay, perfect. And now let's get our rotational thingy here back where it belongs. And now let's make this show everything again. View. Come on. Where is it? View, single page. Perfect. I guess what we now need to do is we need to implement the falling thingies here for all our different digits exactly in the same way. So I guess we have to implement this for 1, for 2, for 3. And I guess I will not bore you with that, but just use some editing magic to speed through the implementation of or writing down of all this stuff. So I guess it's time for some magic. Okay, there we are again. And yeah, what should I say? Through magic, everything is here now. And we have actually implemented this exactly like our sketches show that. So I guess we can now get rid of this and that. Hopefully, if we have any errors there, I haven't tested this yet, we might need to confer with this document again. But as you can see, I have now for every of the digits our sketched out Tetrominos here. So we should actually be able to go ahead and where did we actually create this or hard code this? Wait, didn't I? Where was that? Tetromino RS? Where did I create? Oh, it was in the digit board, wasn't it? Yeah, I created the 0. So let's see what happens if we put a 1 in there and then start here again. So now it forms a 1, and this one is only a little bit dark. But if I run it again, you can see that this actually is a 1. Yeah, perfect. So this works. Let's see, can we do, what would be a nice shape? Maybe a 4 or something like that. That has a little bit more of those. Yeah, that's actually quite nice. We now have Tetrominos that form a 4. That's actually really cool. Okay, so this seems to work out. So I guess we can test all our digits while implementing the next step that we need. Because what we need is we need a way of having all of those Tetrominos fall down, and then we need to be able to change them, those digits, so that the rest of them falls out of the screen and new ones can come in. And how would we actually do that? I guess we now have this in a separate board. So each of our digits would be a separate board, which is fine. They don't collide with each other. They are in different. They will be in different X sections of the screen. So we can actually implement it like that. That may even make things a little bit more performant. No, we calculate collision based on the whole canvas, so ignore me. However, it shouldn't be any problem at all. Okay, so let's see. How did we the last time implement this board exactly? Because I'm not 100% sure anymore. we have, first of all, our would collide and so on function that does the collision. There's our board. Our board has a list of tetrominos that are currently within it and are rendered. Okay, I see. They have a virtual y-stop. That is the thing that we want to stop all tetrominos at and then have them falling out again once we decide to exchange them with something else. And when we add them, we are simply pushing them in the tetromino list. And when we are rendering them, we are iterating over them. And then we are rendering them. Okay, that makes sense. And when we are updating them, that is actually the part which decides if they are falling or not. We are iterating through all of our tetrominos. And if they are stopped, oh, okay, we implemented a stopped parameter on our tetrominos. So if they are stopped, if they are not stopped and they would not collide with another tetromino, then they are moved forward. And if they have reached the virtual stop, then we set the stopped. Okay, can we now simply say you are not stopped anymore, and then they would actually fall out the screen? I'm not sure, could we? So maybe we could do something like pubfn clear tetrominos, or yeah, it is kind of a clear tetrominos. So it's not really clearing them. It's maybe just initiate fall. Yeah. Okay. So could we actually do that? And it takes a mutable self. And it goes for tetromino in self tetrominos dot itermut, and we just take all of those and we say tetrominos stopped equals false, so that they should actually then fall out of the screen. And now if I do something like, could I implement, let's see, in the digit board, I could do something like, have a possibility to exchange this animation. So we could do something like, let's see, pub function, set digit, and we put a digit in there, which is a digit actually. And of course we need a mutable self. And this would simply go ahead and do something like self animation equals digit into, and self index equals 0, and self updates since last anim 0. Yes. Okay, so this should actually then cause this thing to take on a new animation. And before we do all of that, we tell the board that it's time to, how did I call this function now? Initiate fall. That it should initiate a fall of the tetrominos that are actually currently displayed. Okay. Yeah, that kind of maybe makes sense. We will see if it's actually that easy. So maybe we can now just reuse this key input code here. Let's remove that. We don't need that testing code anymore. So maybe we can now do something like, if space is pressed, then we will change the tetrominos. So we will just do as board set digit 1. Currently we will simply hard code it. However, we can make it dynamic later on. We will anyhow need to use timing stuff later on, and so okay, let's see what now happens if I run this. So the 4 is falling in. If I press space, is this one falling out then? Okay, it's not it. Okay, one of them. Oh. Okay, the other ones are not set stopped because they haven't reached the they haven't reached this Y barrier yet that we set, because they are simply lying on top of each other. So they are not in a stopped state. Oh, that's an interesting thing there. That's an interesting thing. The question is, can we handle that with a simple Boolean? Because we kind of have to mark that we now want to go through this line when they... I guess we might need some sort of a tri-state there. Let's see. However, I guess I know maybe how to do this. Okay, let's see. We need... Where's our Tetromino? Yeah. Where's there is this thing. Okay, if we have not stopped, but something like fall, and we have some sort of false state here, which we need, of course, to define. So we have an enum false state, and this one would be in, out, or hold. Okay, so I guess we will make this one derive, debug, copy, clone directly so that we don't get into any problems there. So the Tetromino now has some sort of false state, which what is actually now breaking? This is actually breaking now. That makes sense, because when we push new Tetrominos in our add Tetromino function, then we want to have a false state of in. Okay, so next broken thing here. When we are, that's already an interesting point. So if we are in the update function and we are I guess we will need something like if Tetromino fall does not equal false state hold, and we are not colliding, then we want to advance. And I guess we can't do that because we need to derive partial equality here, which should actually be enough for us to make this comparison. Yeah, nice. Okay, this works. So if it is not on hold and it would not collide, then we advance it. So if it actually reached the virtual stop, then we do Tetromino state is fall, was it? No, wasn't it? Yeah. Come on, false state is then hold. So if it reached the virtual stop, we set it on hold. However, we need something else here, don't we? So if it's not hold and it would not collide, then we want to advance it. So it would advance it actually in the out state as well. What we need here is we need, if it's reaching this line and Tetromino.fall is not false state out, then we want to set it on hold, because when it's on its way out, we don't want to break its fall. So if I now set here in initiate fall, let's call it initiate fall out, and I say I want the fall now to be false state out here, then it should actually all of the Tetrominos should fall out. Let's see if this works, if I've done this correctly. So we have now the 4. If I now press space, the 4 should fall out of the screen while the 1 should come in. Great. Okay, I like that. I should be able to repeat that with a 1. I replaced the 1 with a 1 now. So that's actually kind of neat. So okay, I like that. Can I now do some sort of simple in-out counter thingy there easily, just to test that all of the digits actually work, because we didn't do that before. However, I like that this is actually kind of easy. So let's quickly see. So what I want. We definitely will need some sort of cleanup. Maybe we should do this quickly now, because otherwise we will forget it. Because what we are currently doing now is we are having them fall out of the screen, but even though if they are out of the screen, we are simply we still have them in this board structure here, which is not really good. So they will stay here. They will always be calculated and rendered and moved further outward of the screen. So we should fix that. So just do that. Let's just do that quickly. Update. So I guess we will need some sort of cleanup afterwards. Now that we can have actually tetrominos outside of the screen, we will need to do something like self tetrominos.retain is the function, isn't it? Yes. So there is this function which we can call on an array, and it is essentially called for every of the thingies here that within our tetrominos array, and only the ones that are actually returning true will be retained. So everything else will be removed from the array, and it actually operates in place and will remove everything from the vector that we don't return true for. So let's quickly see what do we actually want here with regards to the true thingy. So I guess what we want is, we want to check if the tetromino's y value is outside of the screen. Yes. However, there is one problem, I guess. The tetrominos have a certain height. And we are always addressing tetrominos by their bottom position, which I'm now starting to question if it's that good of an idea. However, which means we need to actually make sure that their bottom position has fallen outside of the screen, so that there isn't something left over from them there. We don't know the size of a tetromino. However, we know that they are a max of 4 pixels in height. So I guess we can simply add that, and yeah, they might be then removed a little bit too late and do a couple more animation steps outside of the screen before they are removed, but that shouldn't be a problem. So actually, if I do something like tetromino y plus, is it actually plus 4? No, wait, it wouldn't be the wrong side. So tetromino y is bigger than canvas.height plus 4, so our kind of tolerance. This will not work because I need that as an I64. It will by default return U32. Yes, okay. Okay, so if that is the case, then we want to... No, wait, it must be exactly the other way around. So if it is less than or equal the height plus 4, then we want to retain it, and otherwise we want to remove the tetromino. This should actually clean up things. Let's quickly see if this actually compiles and runs. Yeah, okay, and then it falls out of the screen and then it's gone. Yeah, okay, that looks kind of correct. Yeah, okay. So now let's do this quick iteration through the digits actually. So how could we actually do that easily? Main. So we would need to switch kind of between those digits here. Would actually be awesome to have something like, could we do something like impl from usize for digit? Can we do that? Okay, so can we do, that would actually be great. Match value, and we simply do something like we are matching the value, and then we are telling it that this is 0 and 1 is digit 1. We will need this anyway in the end, because we somehow will need to map single digits of our timestamps to their corresponding digit representation. So I guess we can even reuse that. So digit 4. However, I'm already seeing that we won't be able to finish this thing up in this session. However, I guess we will have some quite nice progress in the end when we are ready with what I'm currently doing here. And then the next time we can really start implementing all of the clock and rendering features. 8, 9. Come on. Digit 9. Okay. So now we have this, and we definitely need something for everything else. We want kind of a panic for now. Digit beyond 0 to 9 not supported. Got. And we will see, we will put the value in there. Or let's say digit conversion. Conversion into digit. Beyond 0 to 9 not supported, got, and so on value. Yeah, that actually is quite okay, I guess. We can panic in this situation. And now we should actually be able to create a digit from a usize, which would make our life a lot easier, because now we should be able to, wait a second, store current digit is a usize, and we do current digit 0 here. And now we can do something like, if the space key is pressed, we will do self.currentDigit plus equals 1. And if it's not self, it is s for the state. If s current digit is greater than 9, then, and we don't need the braces there because we are in Rust and not in JavaScript or something like that, we do something like current digit equals 0. And we then will simply do s.board.setDigit, and we do s.currentDigit into. Okay, nice. So now we should actually be able to cycle through the numbers. Oh, we are still starting with a 4, don't we? Aren't we? So I should do some initialization. Where is the initialization actually happening? That is somewhere in our digit board, isn't it? Yeah, I definitely need to do something about initializing this properly somehow. Maybe even making it optional so that it doesn't need to display any. That would actually kind of make sense. Okay, but now we are starting with a 0, and if I press space, a 1 should appear, and now a 2 should appear. Okay, that's really nice. And now a 3 should appear, and a 4 should appear, and a 5 should appear, and a 6 should appear, and a 7 should appear, and now we should have an 8. Great. And we should have a 9. And then it should go back to 0 again. Okay, that's great. If I now do this too fast, what would actually happen? It would actually work out. It would, yeah, because I made it so that it would stop giving out the. Oh, that's actually nice. So it's already handling too fast starts there. That is actually a nice thing. What I definitely think I want more time a little bit more delay between the falling out of the numbers and the new numbers coming in. And I may want to kind of make this a little bit more random, so that there is a little bit like a randomness of 1 to 2 steps between each of the tetrominos that are falling down. Actually, that would actually be a good thing, I guess. And we definitely have to do something about the colors, because as far as I remember Tetris, all of the different Tetris blocks have the same color. So the different types have the same color. So something like this J block here, for example, has always the same color. Something like this straight thing has always the same color, if I remember correctly. Not 100% sure that we want to do this in the end. However, we want a little bit more distinguished color palette than this randomness that we have here, which makes somehow the digits a little bit hard to read sometimes. So we will need to see. Maybe we want specified colors for each of the digits. That could actually make sense as well. So to kind of have a little bit a neat little thing here that shows us the different creations of those things. However, I really like that, and you can already see that now we have everything there in order to actually create our clock. We only need to kind of devise a way of, first of all, getting the time, then dividing it up into digits, then creating more of those digit boards, so that those falling digits down there, like 4 or 6 if we want to display seconds, and then we need to properly update this when the time ticks along. And we may need to implement something that actually holds time for a specific time before rendering it again. Because if we actually would render every second, then something like this would happen. Then you would only see falling tetrominos, I guess, and it would never actually stop in the second line, because it needs more time to fall down and reach its target than then it is needed to actually or then the time is ticking away. So. However, I really like that. I really like the state that we currently have, and I can see how we can easily build upon that to finish up our clock, and that is actually really nice. And in the end, we will have a Tetromino timer in our terminal that is actually displaying the time using Tetris blocks, and I love it. I really love it. That will be awesome. Okay, so I'm just playing around here with this with this thing. Let me stop there. I hope you enjoyed implementing this as much as I did, and I hope you will join me in the next one. So please hit the subscribe button if you want to be informed when it is time for the next video, and please give this video a thumbs up if you liked it. If you have gotten so far until now, I guess you will have liked it, so please give it a thumbs up. It really helps with the algorithm. And please leave me a comment if you have any questions or just want to tell me that you liked that or something like that. Videos with more comments actually help the algorithm as well to decide it is more worthwhile to display others, because there is more community engagement. So if you want to leave me a comment, it is highly appreciated. And if you have any questions, ask there anyways, so that I can answer it. So I hope to see you in the next one, and have a good day. Bye!